Okay, so inductive, you're going to see inductive and conjectures on your homework. For inductive reasoning, inductive reasoning, I just need to remember that this is patterns. That's all it is. It's patterns. All we're looking for is a pattern. All right, so with your highlighter, y'all want to highlight the word inductive reasoning, and y'all want to highlight the word conjecture. We're going to highlight 3 words on this one. Your conjecture is just going to be your hypothesis. It's just this part right there. Just hypothesis. So highlight the word hypothesis, all it is. All right, so what we started with was looking at movie dates. And here's some show times for the movies. We have 8:30 a.m., 9:45 a.m., 11 a.m., and 12:15 a.m. How are the times changing? Where are they going by? An hour and 15 minutes. So all we're doing is we're changing the time by an hour and 15. Okay, so that's what you're going to tell me. You're going to tell me, how is it changing? What are we doing? And we're going to say show times vary by 1 hour and 15 minutes. And it doesn't have to be these exact words. It can be however you want to tell me. I'm the only one reading it, me and you. All right, so if I add that additional hour and 15, what would the next time be? 1:30. Okay. So we looked at some numbers. We also looked at some shapes. This one's a star. What do you notice is changing with the star? The shading, right? What direction is it going? It looks like it's going clockwise, right? It went down to the right, down to the bottom, up to the left. So if I draw the next picture, where is the shading going to be at the next picture? On the left. We can say the shading rotates. I had a class say the whole shape is rotating clockwise. So we can say the shape rotates clockwise. All right, so again, wording it's in your words. Your words and your friend's words can be different. It's okay. All right, look at the next one. How am I getting from 2 to 3? So some kids had questions like this on the homework. They go, Ms. Carranza, I don't know what the pattern is. I tell them, okay, well, how can we get from 2 to 4? So how can I get from 2 to 4? Plus 2. Okay, so you're adding 2. So not necessarily adding 2, but you're going to ask yourself, can I add to get from 4 to 12? No, I can't add anything to get from 4 to 12? 8. I can do plus 8. Can I add to get from 12 to 48? What would it be? 32? Not 32. 36. Do y'all notice a pattern there yet? No, right? Nothing that's obvious. Okay, and it'll happen on the homework. So then you're like, okay, well, adding doesn't work. Can I multiply to get to 4? Yeah, what would I multiply by? Times 2. What would I multiply to get from 4 to 12? To get from 12 to 48? Okay, are you seeing a pattern now? Okay, so then it would be times, and then times, which would be 1,440. So this is how you would approach the homework. If you're getting from one term to the next one, you want to ask yourself, could you do the same operation in the sense of, can you still add? Can you still multiply? Can you still divide? Because it's not going to always be the same number. In this case, the number was changing, but we were multiplying. Okay, so then if I have to put this in words, how would I put it in words?
The numbers are multiplying by numbers increasing by 1.
Okay. Repeat that for me, Miss Charlotte.
The numbers are multiplying by numbers increasing by 1.
Numbers are being multiplied by numbers increasing by 1. What did they start with? What number did they start multiplying with? Starting with 2. All right. And it could be something different. Yesterday we did a different statement. So again, doesn't always have to be something exact, but something to get the idea to me. Okay? All right, when you're ready, we'll go to the back side. Yeah, nice and short notes, right? All right, so then on the back side, we're going to do conjectures. Remember, conjectures is just a fancy word for hypothesis. That's all it is. So the sum of two odd numbers. Somebody give me two odd numbers.
6 and 9.
Odd.
Wait, I mean,
It's okay.
3 and 9.
3 and 9. 3 plus 9 is 12. All right, give me another set of odds.
11 and 11.
11 and 11 is 22. And one more.
7 and 3.
7 plus 3 is 10. All right, and this was from the warm-up we had looked at, right? So what do you notice about the outcome here?
They're all even.
They're all even. So you're going to start off with this. You're going to say the sum of two odd numbers is always even. That's it. The sum of two odd numbers is always even. All right, so you'll just come up with some examples, just 3 or 4 till you see a pattern. All right, let's come down to counterexample. So this is the last one we were going to look at, is counterexample. So a counterexample is where you're proving the statement to be false. You're not giving me an example. You want an example that proves the entire statement to be false. So here I have, if n is a real number, then n squared has to be greater than n. So what they're saying is if I plug in any number here, I'm going to say 2. 2 squared is greater than 2, and that's true, right? Because what's 2 squared? 4. Is 4 greater than 2?
Yeah.
Yes. Okay, I want to prove this to be false, though. Not the first part. I want it to be a number, but I want n squared not to be greater than n. Can y'all think of any example that it would be false?
0.
Yes, Michael? Negative?
A negative number for n.
A negative number for n? All right, so let's do negative 1. So let's do negative 1 greater than negative 1. What's negative 1 times negative 1?
2.
Negative times a negative is a
Positive.
positive 1. Is positive 1 greater than negative 1? Yeah.
0.
0? So 0 squared is greater than 0. Will that work? What is 0 squared?
0.
0 is 0 greater than itself? No. Okay, what else?
Positive 1.
A positive 1. We wanted it to be false. Yeah, so this one works. What's 1 squared? 1. Is 1 greater than 1?
No.
No, these are counterexamples. This is what we want. We want the ones that say no. We want the ones that say no. So either one of these would be correct. We want it to be false. These are counterexamples, not an example. We want counterexamples. All right, so let's look at the last one. The last one says j to k is equal to k to l. K is the midpoint of j to l. Can we draw j to k to be equal to k to l, but k is not a midpoint? So they're thinking this. They're thinking that if this is equal, this is the only way I can draw j to k equal to k to l. Is that the only way we can draw j to k equal to k to l? How else can we draw it? Draw them separated, but k needs to be, they both have to have k on it though.
Reverse.
Like an angle.
Reverse like an angle. All right, so we're going to draw it like an angle. What has to be the one piece that connects them? K, right? Because they both have to have k in common. And I can mark them equal. Is k a midpoint? Is it in the middle?
Yeah.
But is it a midpoint? What is this called? Do you remember for an angle?
Vertex.
A vertex. Yes, so this is a great example of a counterexample. This would be a counterexample. All right, last one. Last one, we're talking about the word problem, sorry. Yeah, we'll have a word problem on the homework. Yours is more of a pattern. This was a counterexample. Here we have that the unemployment rate is the highest in the cities with the most people. Can you find me a county that would be a good counterexample that would prove this to be false?
Mitchell.
Mitchell, why Mitchell?
Because it has a low population and it's the unemployment rate is higher than Hopkins, the higher one.
Oh, is there a better one though?
Maverick,
Maverick. Why Maverick?
because it has the highest percent with one of the lowest populations.
Yeah, it has the highest rate with one of the lowest populations, right? It has the highest rate with one of the lowest populations. All right, so we could go with the highest rate and a lower population. What else could we go with?
A high population for low rate.
A high population with the low rate. So we could have also used what other city? Who has the highest population?
El Paso.
We could have gone with El Paso as well. All right, we can go with Maverick, right? We can go with Maverick as our final answer, but you could use El Paso as well.